Alright, so today we're going to take a look at how to use the coordinate plane and things like slope and distance and midpoint to prove a shape as a parallelogram. We'll start right here with this one. Here we're going to use the idea that the opposite sides are parallel. Okay, we're going to use the theorem that says the opposite sides of a parallelogram are parallel. So we're going to find slope. We can prove lines to be parallel. We can prove AD is parallel to BC if we know that they have the same slope. So we are going to find the slope for these coordinates that are given right here. So the slope of AB, we're going to find that. We're going to find the slope of BC. We're going to find the slope of CD. And we're going to find the slope of AD. Okay? Now a drawing is useful if you want to sketch this or if you want to put a coordinate plane on your paper. That's fine. That's totally a great idea. So I have magically done that. So I'm going to take this, and I'm not going to just use the picture. I'm going to check it. And sometimes the numbers will be too big that the picture won't help. But here we'll take a look at it. So AB, A is 1, 4, so over 1, up 4. B is 3, 5, so over 3, up 5. Okay? So let's find the slope of AB. It's positive, and I can look right here and I can count and show that it's 1/2, or I can do the change in Y over the change in X and I get 1/2. Let's take a look at BC. C is 6, 1. That's over 6, up 1. Okay, that is down 4 and over 3, so it's negative 4/3. And again, I could do that with the picture, or I could say, the change from 5 to 1 is 4, and from 3 to 6 is 3, and so I get negative 4/3. Sorry about that. Whew, little poltergeist action there. And then, let's see, D, so CD, we need D now. D is at 4, 0, so 4 zeros here. So the change from C to D is, and that's this line right here, that's up 1 over 2, that's 1/2 again. From C to D, it's a change in 1, and then 6 to 4 is 2, so it's 1/2. And then from A to D, this last line over here, so from A to D, will be down 4 and over 3 again, so that's negative 4/3. So because we have, and let's make sure we're very clear here, this is A, this is B, this is C, and this is D. And what we have is we have opposite sides of a quadrilateral, because it's 4 sides, and we have the opposite sides have the same slope. So that shape, we can say, yes, this is a parallelogram. Okay. Whoa. All right. So let's take a look at another type of question like this. So if the opposite side, we know that the opposite sides of a parallelogram are congruent. So we're going to use what we know about congruence. Well, to know if this distance here and this distance here are the same, and if AB is congruent to CD, it would be useful if we had distance. So we're going to find the distance between those points that were given here on this one. So let's take a look. We'll draw it again because it's good practice. But we're going to do the math. So that's negative 3, negative 2. That's A. B is 2, negative 2. C is at 3, 1. This is B, this is A, this is C, and D is at negative 2, 1. Okay? So there's the shape that we're working with. And we want to know, is that shape, by definition, a parallelogram? So what's nice for us here, that's D, is that the distance of AB and DC is really easy. So the distance for AB, we can just count because it's a horizontal line. It's 5, all right? So that's easy. Same with DC. The distance of DC is 5. Now we just need to do the distance formula for AD and BC and see if they work out to be the same. So the distance for AD, so that is the change in X from A to D. So negative 3 to negative 2, and it's that number squared. So 1 squared, which is 1, plus the difference or distance between the Y's. So that's negative 2 to positive 1, so that's 3, so that's 9. Okay, so it's a square root of 1 plus 9, which I don't even need to change that. I can just say the square root of 10. That's fine. I don't need to know what the decimal is. I just want to know, is AD the same as BC? Okay, so let's take a look, is the distance for BC. So the change in X, squared, so 1 squared is 1. And then the change in y squared, so the difference is 3 squared is 9. And that equals the square root of 10 also. So this is a parallelogram because the opposite sides have the same distance. The opposite sides are congruent. Let's take a look at another one. Here it says the diagonals of a parallelogram bisect each other. Okay? So if the diagonals, if this is congruent to this and this is congruent to that, then we have a parallelogram. Okay? So we're given some points. So to do this, again, let's throw a coordinate plane on here. I think the coordinate plane on this one can make the problem a little bit complicated. So I might draw the initial shape. And actually, you know what? I changed my mind. Look at that. On the spot. Just pushing buttons again. I'm going to change my mind. I'm going to do this without the coordinate plane. I think we got to understand that what's actually going on, and maybe not seeing the picture might help us. If you want to draw yours, you draw yours. You have a blast. I'm going to draw a sketch of mine just so I have an idea of what it looks like. But I'm not going to draw it out. Here's m is at 3, negative 5. N is at 0, 2. So that's n. That's m. P is at 4, negative 1. And T is at 7, negative 8. So this is my shape, something like this. Alright, so this is my parallelogram. And I want to know if the diagonals bisect each other. Okay? So I'm looking for the diagonals. I'm looking for, does NP, or does NT bisect MP? I'm going to add a point in here. We're just going to call it O. Alright? Because really what I want to know, if the diagonals bisect each other, then NO should be congruent to OT. And MO should be congruent to OP. How are we going to find this O, though? That's a big deal. And the answer to that is that we're going to use the midpoint formula. Okay? So we'll take MP. We'll start with MP. And to find the midpoint there, we're going to add them. So 3 plus 4 over 2. And we'll add the x's and divide by 2. And then we'll add these, negative 5 plus negative 1 over 2. And we get 3.5 and 3. Negative 3, excuse me. Okay, for point O. If you want to check that over here, we get the same thing for N and T. If you take 2 plus negative 8, that's negative 6, and divide by 2, that's where we got our negative 3. And 0 plus 7 divided by 2 is 3.5. So the same midpoint either way. So now I'm going to find some distances. I need to know, does MO equal OP? And does NO equal OT? Now there are going to be some decimals and stuff in here, which is fine. We just got to make sure that when we're simplifying, and things like that, that you're staying consistent with how you're doing it. I'm really just looking for the same number under the radical, so I don't even care what the square root equals. So from M to O, so this is the square root of, the difference between these two x's is 0.5, okay? Get out my handy dandy calculator over here. So 0.5 squared, if you're curious, is 0.25. All right, so the difference there was 0.5. So that's 0.25. Plus, so that was M to O, and then it was the x, and so the y's for MO is from negative 5 to negative 3. That's 2, so that's 4. So we're looking at 4.25 here, the square root of 4.25. And we want that to be congruent to OP. So let's see, the square root of the O, the difference here from O to P is 0.5, so that's 0.25 when we square it. And the difference from negative 3 to negative 1 is 2, and 2 squared is 4. So again, that's the square root of 4.25. That's the ugliest radical ever. All right, so we have that one. Let's take a look at NO. So we know those two, we can mark those. That does bisect that. Let's check NO. So from N, the x values, that's 0 to 3.5, and 3.5 squared is 12.25. Plus, that's the x value, and then the y value is 5, so that's 25. Okay, so that's the square root of 37.25. Okay, then let's check OT. So from, that's 3.5, we already know 3.5 squared is 12.25. Okay, and that's from 7 to 3.5. And then from negative 8 to negative 3 is 5, and 5 squared is 25. And again, I don't need to know what the square root of 37.25 is. I just need to know that these two are the same, because that proves that this bisects this, and now I know that the diagonals bisect each other. Let's take a look at another one. Let's put that away. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So here, we're just going to pick one side. You know, if this is parallel, here, let's actually do it in the order. It says if AB is congruent to CD, so if that's congruent to that, and these same two sides are parallel, that's a parallelogram. Or if this is congruent to this, and that is parallel to that, then we have a parallelogram. So with this shape, the one that's given here, I'm going to again draw the quick sketch because I think that's a good practice for us. That's -5, 0, -3, 5, 3, 7, and 1, 2. Okay, so here's my shape, something like that. It's R, S, T, U. So I'm going to, which side you pick, it doesn't matter. I'm going to choose RS. I want to know what RS equals, the distance, and TU. And then I'm going to find the slope of RS and the slope of TU. And these should all be the same. So RS, as far as distance formula, that's the change in the x's squared. So -3 to -5 is 2, and 2 squared is 4. Plus the change in y's, which is 5, and 5 squared is 25. So the distance of RS is the square root of 29. TU, from the x values, that difference there is 2, so that squared is 4. The difference is 5, so that squared is 25. And so the distance there is 29. Hopefully some of us who are struggling with distance from midpoint and those kind of things, slope, this is going to help clear some of that up for you because you need that stuff to do this. The slope of RS is the change in y. I know it's positive from looking at the picture. Change in y is 5 over the change in x, which is 2. And the slope of TU, the change from 7 to 2 is 5. And from 3 to 1 is 2. So it's a parallelogram. And I've proven it because one pair of sides is both parallel and congruent. Okay? Let's take a look at the last one. So let's take a look at this one. Here we have a parallelogram, and we're trying to prove that or a quadrilateral, and we're trying to prove that it's a parallelogram based on the opposite angles being congruent. So we're given some angles here. The first thing we need to do is we need to solve for x. Now to solve for x, if this is a quadrilateral, these 4 angles should all add up to 360. So that's what I'm going to do. I'm going to do 3x plus 18 plus 4x minus 4 plus 2x plus 32 plus 3x plus 26 and get 360. I combine like terms and I get 12x plus 72 equals 360. Then I solve for x and I get x equals 24. Now what I'm going to do with that is I'm going to plug that 24 in for each of the angles. Okay, so angle A would be 3 times 24 plus 18, which is 90. Angle B would be 4 times 24 minus 4, which is 92. Angle C is 2 times 24 plus 32, which equals 80. I already know that it's not now, right? Because I got 3 different angles. Angle D is 3 times 24 plus 26, which equals 98. So I can say that ABCD, this quadrilateral, is not a parallelogram because it doesn't work. Okay, it doesn't. The opposite angles are not congruent. All right, that's it. If you have questions on that, bring them with you when you come to class. Jot those down on the blank space that you have in your notes there, and we'll answer questions when you get to class. Thanks, guys.